All right, let's do this. You're about to get a crash course in artificial intelligence. We're going to cut right through all the hype and get straight to what you actually need to know. Seriously, in the next 5 minutes, you are going to understand the technology that is changing everything. Let's jump in. So, how does Netflix just know what you want to watch next? Or how does your phone unlock with just a look? You might think this stuff is science fiction, but guess what? AI is already a huge part of your daily life. It's the brain behind your streaming recommendations. It's the guard that keeps spam out of your inbox. And it's the navigator getting you through traffic. This isn't some far-off future. It's right here, right now. So what even is this stuff? At its heart, the idea is actually super simple. Let's just start with the biggest picture possible. The whole goal of AI is just the science of making machines smart, giving them the power to do things that normally require human intelligence, like seeing, speaking, and learning. Okay, so what's the textbook definition? Artificial intelligence, or AI, is the big, broad field. I want you to think of it as the great-grandparent of everything else we're about to talk about. It's this huge umbrella that covers any attempt to make a computer think or act like a human. But inside this giant universe, things start to get a lot more interesting. See, tucked inside that giant field of AI is a really important piece called machine learning. And this is where things get cool. This is where we stop telling the machine exactly what to do, step by step. Instead, we just show it a ton of data and let it figure out the patterns and learn for itself. And if we zoom in even deeper, inside machine learning, we find the absolute powerhouse of modern AI, deep learning. This is a special kind of machine learning that uses these complex, layered structures that are actually modeled after our own brains. We call them neural networks, and they are the reason AI can do such incredible things today. So we've got this little family tree, right? AI is the grandparent, machine learning is the parent, and deep learning is the star of the show. Now, both machine learning and deep learning learn from data, but how they learn is what makes all the difference. Let's put them head to head. Okay, check out the human role here. With old school machine learning, you needed a human expert to sit there and tell the machine, hey, look at this feature. This feature is important. But with deep learning, the network figures out what's important all by itself. This one ability to learn directly from raw data is what powers the coolest stuff we have today, from self-driving cars to facial recognition. So, how does the magic actually happen inside the box? Let's pop the hood on the engine of modern AI, the large language model, or LLM. Yeah, this is the tech behind things like ChatGPT. At its core, it's just a neural network that's gotten incredibly good at one thing, guessing the next word in a sentence. But how does it understand language well enough to do that? Well, it's kind of like a three-act play. First, it breaks our language down into pieces. That's tokenization. Then it turns those pieces into math, using vectors. And finally, it figures out the context using this brilliant trick called attention. Let's walk through each act. First up, Act 1, tokenization. The AI doesn't see words the way you and I do. It shatters our sentences into these meaningful little chunks called tokens. So a word like running might become 2 tokens, run and ning. This helps the model really get the building blocks of grammar and meaning. All right, Act 2, vectors. Every single one of those tokens gets turned into a vector. Just think of it as a set of coordinates on this huge invisible map of meaning. On this map, words that mean similar things, like king and queen, are plotted really close together. It's how the AI literally turns words into mouth. But this brings up a really interesting problem. How does the AI know if the token apple means the fruit you eat or the company that makes your phone? The token is exactly the same. The answer, like the quote says, isn't in the word itself. It's in the words floating around it. And that brings us to our grand finale. And this is where Act 3, attention, steals the show. This mechanism lets the AI look at all the words around apple and decide which ones are important for context. So if the word tasty is nearby, its vector literally pulls the apple vector over to the fruit section of the math. If revenue is nearby, it gets pulled over to the company section. This is it. This is how AI understands context. So we've seen how it thinks, but how does an LLM get so ridiculously smart? I mean, you can't have a human teacher for every sentence on the entire internet, right? The solution is this revolutionary technique where it basically teaches itself. It's called self-supervised learning. Instead of needing people to label everything, the AI just takes a gigantic pile of text, like all of Wikipedia, and it makes up its own games. It's like a massive game of fill in the blanks. It will hide a word in a sentence and then try to guess what word it hid. By doing this billions and billions of times, it learns the patterns and rules of language completely on its own. It's a total game changer. Okay, so now we have this super powerful model that's been trained on like half the internet. But how do we make it actually useful for a specific job? Let's do a lightning round of the key techniques that put this raw intelligence to work. First up is fine-tuning. This is where you take that general model that knows a little about everything and you send it to get a PhD in a specific subject. It's like sending a brilliant college grad to med school. For example, you can take that base model and then train it on thousands of medical textbooks. And boom! You've just created a specialized AI that can help doctors diagnose diseases. But what if the information you need is brand new, or it's private to your company? That's where a technique called Retrieval Augmented Generation, or RAG, comes in. Think of it like giving the AI a special library card that lets it look up real-time information it wasn't originally trained on. For instance, you could give an AI access to all of your company's internal manuals. Now, when a customer asks a really specific question, the AI doesn't have to guess. It can just retrieve the exact right answer from your private files and give it to them. So we've made the AI an expert, we've given it a library card, but what if it could not only answer questions but actually do things for you? Well, that's the next step. AI agents. These aren't just chatbots, they are systems that can take action in the real world. Imagine a travel AI that doesn't just tell you about cheap flights. No, it can actually go to the airline's website, fill in your details, and book the tickets for you, based on what you like. It's not just an information source anymore, it's your personal assistant. And just like that, we've climbed the entire ladder. We started with this simple idea of just making machines smart, we looked under the hood at how they think, we saw how they become experts, and we've ended up with autonomous agents that can act on our behalf. We've gone from zero to a powerful co-pilot for our lives. So, in just a few minutes, you have grasped the core concepts that are driving the single biggest tech revolution of our lifetime. You get the difference between AI, machine learning, and deep learning. You know how an LLM thinks and learns. The question is no longer, what is AI? The real question is for you. Now that you know the building blocks, what are you going to build with